Good morning everyone. This is my program about the doubly linked list. This is my main method, main class. This is this main class will help the user see an input for the program to work. The menu will show a group of options. It will add the head, add the tail, insert after a specific element, delete from head, delete from tail, delete a specific code in the list, display the head, display the tail, search an item in the list, print a forward traversal of the list and the backward traversal. This is for the demonstration of how a doubly linked list works. First we're going to discuss about doubly linked list operations. Here is shown the operations of every options. First, this is where we put the method to check if it's empty. If head is equal to null and tail is equal to null, then true. If else, false. So the first method, which is printing the first element or the head, so system head up equals the head plus head item. Second one is for printing the tail, which is the same as the tail. So the third is adding first element. So we're gonna check first if the list is empty. So new node equals new node, null item, null. So if head is equal to tails equals new node, else node new node equals new node, then null item head. So head equals the new node, which is the head that previous equals to the head. Then the fourth one is adding the tail. So it's just the same as the adding the head, but with the else method there is a change, which is the tail, and tail is equals to the new node, then tail is that previous that next equals tails. So that's the difference between adding the tail and the head. So fifth is deleting from the head. So we're gonna check if it's empty. Then if it's empty, we're gonna print the list is empty. Else we're gonna put head is equals head that next, so that head previous equals null. We're gonna delete the previous node. So second is the public void delete from tail. Deleting from tail is also checking if the list is empty. So if it's empty, print list is empty. Then else, if tails equals tail that previous, then tail that next equals null. So we're gonna delete from the tail. Print forward. Node current is equals to head. So system print and we're gonna print the forward. While current is not equal to null, keep on printing the current dot item. Then current is equals to current dot next. So if the current is equal to null, then the method will stop. It's just the same with the printing forward. Printing backward, the difference is we're gonna use the tail as the current node. So it's the same, current equals is not equals to null, print the current dot item, then current is equal to current dot previous. So after that, I check after the public void insert after. I'm gonna check in target, we're gonna ask for the target item and the item which will be inserted. So node current equals head, while current that item is not equal to the target, and current that null, current is not equal to null, current that equals current that next. So we're gonna search for the item. If current that item is equals to tail that item, Then we're gonna add the method add last element. We're just gonna put the last element. So else, node new node is equals new node. So null item null. Node q, because the current the next one, node q is like the reference for the next current. So current the next is equals to new node. Then the new node that previous equals to current. It will become the previous node. Then the new node that next will be the q, will be the current that next. So q that previous is equal to the new node. It will insert there the item. So public void delete node. So gonna ask for the item. Node current equals head. So if item is equals to the head item, delete from head. Just gonna call the method delete from head. As if item is equals to tail that item, we're just gonna call the delete from tail. Else, while current that item is not equals to item and current is not equals to null, keep on searching. Current is equals to current that next. So node P is equals to current that previous and node Q will current that next. So P that next equals Q and Q that previous equals to P. Just gonna put the data there. So the last thing is the public void search item. We're gonna ask for the item. So int 1, int I equals to 1 is for the location of your item. So boolean flag equals false, node current equals head. So if it is empty, print this is empty. While current is not equals to null, if current that item is equals to the item, flag equals true, then break, it will return to it will finish the method here, and it will come directly here. Then if flag is true, then print element is present in the list of the position plus I. So here, if it's not true, then we'll be proceeding here. Current equals current that next, then I plus plus for the position. So else system print element is not present in the list. Now we're gonna try if our program works. So here we're gonna try 1. We're gonna add 12. Then we're gonna add from the tail. So it will be the next part. 13. We're gonna add another 3 more elements. 15, 16. So now the 5 elements have been inserted. We're gonna try the insert after. So insert element to print after. So we're gonna print after 15. So try that. Enter an element which is 20. So we're gonna show the forward and backward traversal to fully understand the node. So 15 here, we inserted after 15, so there is a 20. So here, after the 15, we inserted 20. So for display head, we display the first item we put. I will put then the tail is 16, the last one. So now we're gonna try to delete a node and element. So we're gonna remove 15. Now it shows here that 15 is nowhere to be found and it is removed properly. So now we're gonna try to delete from the head, which is 12. Now 12 is nowhere to be found. And now we're gonna try delete from tail. So tail 16 has been deleted as well. So search item. enter the element. So we're gonna find 14. Element is present in the list at the position 2. So here 2, 1, 2, 14. So I'm gonna display the traversal, forward traversal, which is 13, 14, 20, and then the backward. So 20, 14, 13. So that's all for my program. Thank you.